Hello everyone, this is John with ziptopia.org. Today we are continuing our RFC 3261 Simplified series with part 2. If you haven't watched part 1, please stop here and watch that part before going through this part 2. There will be things that we'll be referring to from part 1. Now, in this part, we will be first looking at SIP messages, and then we will look at the two mandatory sections that create the SIP messages: start line and message header. And the other section, message body, is optional, and we won't be discussing it here in this part. So, from last part, you might recall that we had a call between Tarzan and Jane, and we looked at those messages exchanged. Now, there's a few different SIP messages used even in a simple call between two endpoints. Now, at this point, it is worth listing the most commonly used messages, most commonly used messages, in two groups: requests and responses, before taking a closer look at these messages. Requests, the most commonly used are register, invite, act, buy, cancel, and options. And the responses are listed, grouped as 1XX class provisional, 2XX class success, 3XX class redirection, 4XX class client error, 5XX class server error, and 6XX class global failure. So both requests and responses are text-based. We did mention this in part 1 as well. Like HTTP, SIP message is either a request from a client to a server or a response from a server to a client. Requests and responses both follow the same format: a start line, a message header, and an optional message body. What distinguishes requests from responses is the start line part. And that will be our next section in this presentation. Start line can be either a request line or a status line. A request line is composed of 3 sections: method, request URI, and SIP version. Similarly, a status line is composed of 3 sections: SIP version, status code, and reason phrase. The method in the request line is simply the function or feature a client is requesting. If you remember, those are the most commonly used ones were register, invite, act, buy, cancel, and options. And the request URI is the address of the endpoint service. The status code in the status line is a 3-digit number used to define the response for machines. And on the other hand, the reason phrase is the associated description of the status code for human users. So, the sample call between Tarzan and Jane could be again used as an example here to go over the requests and responses. The first screenshot will be the invite request from Tarzan's SIP phone at IP address 192.168.1.20, and it's sent to the *now PBX at IP address 192.168.1.3 in hopes to reach Jane's extension 4444. In this case, as the highlighted entries demonstrate, the SIP message is a request with a request line, a message header, and an optional message body. The request line uses invite as the method, SIP column 4444 at 192.168.1 1.3 as the request URI and SIP version 2.0. The next screenshot here is a 1xx class provisional response with a status line and a message header. Keep in mind, message body is optional. Here the SIP message doesn't have the optional message body. The status line in this case is composed of SIP version 2.0, status code of 100, and the response phrase of trying to explain that status code to human users. The session initiation continues with another response here, a SIP message with a status line, a message header, and again, no message body. The status line here indicates SIP version 2.0, status code of 180, and the reason phrase of ringing to explain the status code to the human users. Similarly, this next SIP message is also a response with a status line, a message header, but now also a message body, which is optional. The status line here is composed of SIP version 2.0, status code of 200, and the reason phrase of OK to indicate the human users that the request was successful. Using the TCP/IP analogy, the one that we did in part 1, three-way handshake at the TCP level, Tarzan's SIP phone sent a message, it received a response, and now it needs to acknowledge the receipt of the 200 OK response with an ACK request. Here is the ACK request message highlighted, and it's composed of a request line and a message header. Now, the not-so-gentleman Tarzan hangs up on Jane, and Tarzan's SIP phone sends out a buy request. As a response to the buy request, Tarzan's SIP phone now receives a 200 response, which indicates that the request, the buy request, in this case the termination of the call, was successful. So as we mentioned earlier, requests and responses both follow the same format: a start line, a message header, and an optional message body. Now that we went through an example to discuss the start line, let's move on to the message header section. The message headers are composed of header fields. An important point here is the fact that the order of header fields does not matter if the header fields are not the same kind. If the header fields to be listed are the same kind, the order is crucial. Header fields have the following structure: name, column, value. Now, another good point here is that all SIP requests must contain at least each and every one of the following headers: to, from, C sequence, call ID, max forwards, and via. This is an extremely important point, so I'm going to repeat this. All SIP requests must contain at least each and every one of the following headers: to, from, C sequence, call ID, max forwards, and via. These 6 header fields are the most important components in SIP requests. Now let's go over these and some other SIP header fields quickly by using the call between Tarzan and Jane as an example. The to header field is pretty much the logical destination of the request, the resource that we are trying to reach. Keep in mind that this value might not be the ultimate destination. In this call, for example, Tarzan is trying to reach Jane as the ultimate destination, but the host portion of the URI is the IP address of the *now PBX. Both Tarzan and Jane have registered their SIP phones to. Also note that Tarzan did not dial the whole URI, he simply dialed 4444. The user agent, in this case Tarzan's SIP phone, is responsible for completing the URI. In our first tutorial, where we registered Tarzan's SIP phone, we entered the *now PBX IP address manually. That's how the user agent, Tarzan's SIP phone, knew how to complete the to header, even though Tarzan just dialed 4444. One final observation is the additional tag in some to header fields. Basically, this tag identifies the other end of the communication, and since the initial invite message above hasn't received anything from the other end yet, in other words, the initial invite is out of dialogue, it doesn't have a tag. Starting with the 180 ringing message, we are seeing the tag added to header field. This makes sense as the 180 ringing means the other end has received our invite message. The other end knows of us, thus we are in a dialogue. And the remaining two header fields will contain tag, as seen in the screenshots here, all the way down to the last 200 OK that signifies that the buy message was successful and the call has been terminated. Here another two header field with the tag in this case. Now, moving on to the from header field. The from header field is very similar to the to header field, with the exception that from header field always has a tag. It is important to note that the host portion of the URI in the from header field is not Tarzan's IP address. Also, if the entity of the client needs to be hidden, you may also see random URIs like SIP column xxxxx at anonymous.invalid used. As for the call ID header field, it is important to know that the values are globally unique for each dialog. In other words, the call ID header field value below must stay the same until the call is terminated, and no other call in the future could use the same value. C sequence header field is composed of a sequence number and a method. This sequence number is used to order transactions within a dialog. It is important to note that the order is created within a dialog. Otherwise, when a call first starts, the initial C sequence can be any value. It's arbitrary. This is an important point, so I'm going to repeat this. It is very important to note that the order is created within a dialog. Otherwise, when a call first starts, the initial C sequence can be any value. It's arbitrary. In other words, two different calls might have two different C sequence values that have absolutely no mathematical logical relation between them in their initial invite messages. However, once a C sequence value is used in a call, it will be incremented by 1 every time a transaction occurs in the call. For example, Tarzan's initial invite message to Jane below has the header field C sequence with the value 24078. If he had put the call on hold, the next invite message would have a header field C sequence with a value of 24079. Since he doesn't put the call on hold, the sample call we had in part 1, the next transaction is the buy message Tarzan sends to Jane. This new transaction is in the same dialog and has the C sequence header field with the value 24079. Now the max forwards header field in SIP world serves pretty much the same purpose, time to live mechanism in an IP world. After careful consideration, the value of max forwards header field, the default value of max forwards header field was chosen to be 70. Every time a SIP message is received by an entity on its route to its destination, the max forwards value will be decremented by 1. If an entity receives a SIP message with the max forwards value of 0, it will respond with a 483 too many hops message and not send the SIP message to the next entity. With the use of max forwards, we avoid throwing away infinite amount of resources when there's a loop. So let's use a rather funny analogy here to explain one of the required must-have SIP header fields, via. Let's say Tarzan finally tricked Jane into marrying him, and he wants to build a nice house in the city for this newly founded family. He fills out a request for permission, similar to creating a SIP message, and signs it before heading out to get other signatures, similar to adding a via entry for himself before sending a SIP message out to the next entity. Now Tarzan is at the homeowners association. Let's say he is at the homeowners association to get their signature on the form before moving on to the next entity. This would be similar to the SIP message being processed by the next entity and that entity adding its own via entry before sending the SIP message to the next entity on its route to its final destination. Well, Tarzan is now at the Environmental Protection Agency to get their signature on the request for permission form before heading out to his final destination, the local municipality. This would be again similar to the SIP message being processed by the next entity and the entity adding its own via entry before sending the SIP message to its final destination. When Tarzan brings the request for permission form to the local municipality, the final destination, they can see the route it took from Tarzan to the local municipality because of all the signatures he got on his way to the destination. Similarly, the final destination of the SIP message sees the via entries and knows the transportation the SIP message used from originator to the destination. Since the entities in this SIP communication all know where they got the request from, they can now send their responses to the respective entity. In other words, via header field tells the entities where to send their responses. I'm going to repeat this. Via header field tells the entities where to send their responses, while via header field tells the entities where to send the responses, contact header field tells both ends of a SIP communication where to send the future requests. For example, when Tarzan called Jane, the invite message from Tarzan had Tarzan's extension as well as his IP address. If the entity between Tarzan and Jane was a SIP proxy, this contact header field would be relayed over to Jane, and as a result, the subsequent requests, including the ACK and buy messages, could have been exchanged directly between the two. So this is the end of part 2 in our RFC 3261 Simplified series. So if you have any questions or comments about this tutorial, please let us know. Thank you so much. Bye-bye.